10 or more precisely 20 years ago. Now it is disbinded into leaves. So this is such small books, and this is one leaf. If you think I can't see anything, that's okay, because it is heavily damaged by mold, so it can't be printed very well. Well, what is in this codex? This codex is Euchologion, and it is Byzantine liturgy, written in 19. I'm sorry. 1229, and it was prayer book. But under the text of the prayer book, we can find some writings of Archimedes, and these texts are extremely important and extremely interesting. So we can find two stages in the history of the codex. Before palimpsestation. What is palimpsestation? Codex was made of parchment, and parchment was very rare. And if you have some codex that you don't need, for example, codex with mathematical text, I think it is not your case, but it was case of some monks in 13th century. They had codex with mathematical writings, and they didn't need it. So they washed up the text, not too precisely, but they washed up the text, and they could use it next time. So they could write across the original text, Euchologion, liturgical text, some prayers. And this is after palimpsestation. The original codex with treatises of Archimedes is from half of the 10th century. And concerning the palimpsest, what does it contain? 175 pages of parchment, and later there was added some several pages made of paper. It is a relatively small book, and it is heavily damaged by mold. And now I can say that the damage wasn't caused by 700 years, but only by last 70 years. We will see later. Focus on the original codex, not on the prayer book. Many leaves, measuredly, contain treatises of Archimedes. With 71 leaves, we say folios, and only small parts contain some other texts, which are extremely important. For example, it was ethic orator, and we found in the codex some new text which wasn't known previously, and we found absolutely new commentary to Aristotle. Unfortunately, it is only 7 folios. On the 7 leaves of parchment, we have commentary to small part of this treatise of Aristotle, and it is commentary to very small part. If this commentary existed to the whole treatise, it should be huge, absolutely huge. We don't have any such huge commentary to categories. We have some folios with biographies of saints and some liturgical texts. We have three folios which are signed Y and Z. We are mathematicians. Well, you can ask where is X? X, Y, Z. The folio X was deciphered, so it vanished, and we have only Y and Z, which are not deciphered yet. I think that it will not be deciphered anytime because these leaves are washed up too precisely, so there is nothing on these leaves of parchment. The part of the codex with criticism of Archimedes was marked as Codex C. And I will speak about Codex C, and this is the original treatise, original codex with criticism of Archimedes. So we can look at it. What does it contain? It was twice bigger than the prayer book, which we have seen in the beginning of this talk. These are the dimensions. Text was in 2 columns, and each column contains approximately 35 rows. There are white margins, and we are happy for that because it was cut up, so the original codex has smaller dimensions, and thanks to wide margins, this cutting didn't cause any loss of text, so we are very happy for that. The codex of Archimedes was written in minuscule, typical for half of the 10th century. We can say it very precisely because in each time scribes wrote in another style. So this is the style of the half of the 10th century. The scribe fortunately didn't understand the text. Why fortunately? Because if he didn't understand the text, he wrote what he saw in the previous text. So he didn't make any corrections, and we have all the text without his corrections. He did some other mistakes, but these are classical scribal mistakes. Some pages are missing today. In the beginning, at the end, and some parts inside the codex. In the beginning, well, and at the end, because the damage mechanical is the worst, so these leaves were wasted. Well, because we don't have beginning and we don't have end, so we don't know about the original extent. of the codex. But I think it doesn't matter. Now we have 61 folios which are fully preserved and 7 folios which are present partially. Well, concentrate on the content. You can notice that these three treatises are highlighted in red. And why? Because these three treatises are the most important. Concerning the plane in equilibrium, we have Greek text from another sources. Spiral lines, sphere and cylinder, measurement of the circle, we have Greek text from another sources. But concerning floating bodies, the book number 1 and the book number 2, we have only Latin translation and no Greek text. And think about it. This is a treatise where we have law of Archimedes. And before the discovery of Codex we didn't have Greek text of law of Archimedes. Here is unique text which wasn't known previously, this method. We will focus on this text. And Stomachion, this text was known only from Arabic fragments, and it is absolutely different from the Greek text which was found in this codex. I said that we didn't know about methods previously, but it isn't absolutely true. We know that something like method Archimedes wrote. For example, from Suda, it is a huge encyclopedia, but it was written 12th century after Archimedes, and here in this huge encyclopedia is written in entry Theodosius. The philosopher Theodosius wrote Spyrica in 3 books. 2 books about day and night, and commentary to Archimedes' method. But we didn't know anything. What does it contain? And I think you heard about Hero. For example, he wrote about the method how to compute area of triangle. If we know ABC, the length of the side of the triangle, this is very well known. And he writes in his treatise Metrica, Archimedes shows in his method that and on another in another place in Metrica he writes Archimedes proves in his method. In his method. This theorem is very interesting, so I supplied some pictures. It speaks about the volume of this section of cylinder. I think it is not necessary to describe by words how this section is made. It is cylinder which is inscribed in the parallel epithet, and here this line goes to the center of the circle in the basis, and the volume of this dark part of this section of cylinder is 1/6 of the circumscribed parallel epithet. It is an amazing theorem because this is part of cylinder, and we compare it with volume of parallelepiped. And Archimedes was very surprised by his own result. So, this is a very interesting theorem, and we know that this is in the treatise of method. But what this amazing treatise contains more? We didn't know before discovery of method anything more. Well, uh, concerning the discovery, here is the main person, Johann Ludwig Heiberg. His secondary education he obtained at Cathedral School in Aalborg, in his hometown. He was very well educated, and he was very interested in math, Greek, Latin. 1871 he came to university, and later he started his Ph.D. studies, which he finished with his Ph.D. thesis, Quaestione Archimedes. And here we saw some questions concerning Archimedes, and look, only 1 year after finishing his PhD studies, he published the first volume of Archimedes' Opera Omnia. This is standard edition of treatises of Archimedes. And in the 19th century, to publish Opera Omnia of some author, it was a huge task, and this task did mostly professors, and this was postdoc. So, Johann Ludwig Heiberg worked on Archimedes, published all the Greek texts of treatises of Archimedes, and now could the story finish, but not. More than 20 years later, Hermann Scheene in summer wrote to Heiberg, and he wrote him that he saw something new concerning treatises of Archimedes. 1899, Athanasios Papadopoulos Karameus worked on catalog in monastery of the Holy Sepulchre in Jerusalem, in Stomachion in Constantinople. And his salary was based not on time, but on amount of pages. So he took codecs described the codex very carefully because his salary was based on amount of pages. What he will write, this will be paid. So he wrote very carefully this catalog, and when he tried to design the codex of Archimedes, he saw prayer book, but behind the text it was something lightweight, and he thought there is something another. This must be palimpsest. On some pages he saw some geometrical figures, and he said, wow, this is not only prayer book, this is book which contains some mathematical texts. He was able to find on some pages the washed up text which he was able to read, mostly on some margins, and 3 lines he wrote into the catalog. And later, change. Later, Hermann Scheene read this catalog and saw something from a mathematical text. And he thought about it. Wow, this is mathematical text. I think that this would be interesting for Johann Ludwig Heiberg. He edited Archimedes and another Greek text of ancient mathematicians. So he sent him information about it. And when Johann Ludwig Heiberg saw the 3 lines which Papadopoulos Kerameus wrote into the catalog, he thought, wow, this is text which I don't know. I edited a whole amount of treatises of Archimedes, and I don't know this part of text. But I know that this is style of Archimedes. If you think that from 3 lines it is not possible, decide if this is text from some treatise of Archimedes or not. Well, it is possible, because Archimedes wrote mostly in Doric, and this dialect you can recognize very easily. So it was clear that here is something absolutely new. And this is Johann Ludwig Heiberg. You see the majestic man. And here is with his colleague. From their correspondence, we have many details from discovery of the codex. Heiberg wrote to Drachmann, and from the correspondence we have many details. Heiberg went to Constantinople next year. He spent there his holidays. We see the 14th July, and in the beginning he was very pessimistic. He thought that it will not be possible to decipher almost anything, that it will not be possible to take photos, that it will be extremely difficult, and that contribution of his journey will be almost nothing. But some days later, he found part of floating bodies, and this treatise was previously known only in Latin translation, and he found Greek, original Greek text. And later he tried to take photos, and finally, after 6 days, he found the method. The codex was very badly readable. Heiberg should read the text which was washed up. If you think that he had some technique, no. He worked in very bad conditions. Concerning the monks, it was very difficult. They didn't want it to borrow him the codex, and he had to work in library where there wasn't enough of light. So he worked in extremely difficult conditions on extremely difficult passages. And think about it in such a way. He worked with codex which was of half of dimensions. So leaves of original codex were, and if he wanted to read first part and continue of the same leaf, he had to go through the codex on another part of the book. So it was extremely difficult to read only one leaf. So he worked hardly on transcription, and he worked hardly on transcription of the absolutely new treatise on method. Heiberg brought his notes back home and a few transcriptions and a photo of one page. In Constantinople lived very famous photographer, and this photographer took photos of the whole codex and sent it to Heiberg in autumn. So Heiberg had his transcriptions, his notes, and later he had also the photographs of leaves. So he worked hardly on improved transcription, and later he published it. Here we can see photo of one page from the codex as Heiberg seen it. This is the photo took by photographer, and this photo was sent to Heiberg. So Heiberg himself worked with these photos. This text is text of the prayer book. It is not the mathematical text. The mathematical text is here in two columns, one and two columns, and the second column. So this is prayer book, and these two columns are the mathematical text, the text of Archimedes. So it was extremely difficult to work with such Greek text. And when he improved his transcription, he published it on 25th January 1907, and it is a very famous article, Eine neue Archimedes Handschrift. And later they made with his friend who was mathematician, German translation. It was sensation because here was published absolutely new treatise of Archimedes. For example, about this big literary find wrote New York Times. Here is part of the article from the newspapers. If you think that this is very short article, no, this is only part of the very long column. If this column would continue to the end, it would continue downstairs, but we don't have such a huge project line. So, big literary find in Constantinople. Concerning the publication, the transcription, if you think about text, yes, it is text, but here there are many gaps. I think we can't be satisfied with this text. But unfortunately, it was sensation, and very quickly it was created German translation and English translation, and moreover Czech translation. And if you want to read method in English, for example, the only English translation which exists is from this corrupted transcription. In the translation, these gaps are hidden, so you can't see it. But here you can see very clearly what is the text on which the translation, the English, the only English translation is based on. I think it is horrible and that it should be improved. Well, Heiberg wasn't satisfied with this text, which was full of gaps. So he now the text, he had photographs, he had transcription, and he absolutely precisely knew where are the gaps and which he couldn't fill up. So he visited the monastery and the library for the second time in 1908 for only 5 days, and he checked the bad places, the gaps, and later he published a very improved edition of the method. And this publication was made in the second critical edition of the whole amount of treatises of Archimedes, Archimedes Opera Omnia. And the method is in the second part of this edition. And after the finishing of the whole work, he delivered the photographs to Royal Library, and everything was finished. I mentioned a problem of translations. German translation is based on the first edition, not on this improved reading. The only English translation of the method is based on the first publication, not on this improved reading. And we are in the Czech Republic, so it is extremely interesting that the third language into which the method was translated was Czech. And it was made in Prostějov, and it translated teacher of grammar school. But we will speak about it later. Well, sum up the history and then move to mathematics. So, overview number 1. Half of the 10th century, the Archimedes codex was created. Somebody who wanted to read Archimedes worked with codex, and he wrote treatises which he was interested in. But after centuries, somebody realized that he don't need any mathematical text, that he needs a prayer book. So some priest washed up the text of Archimedes and wrote on the leaves of parchment a prayer book. If you think that it was very horrible how he could do it, I think we can thank to the priest. Why? Because if you washed up the treatise of Archimedes and write on it some prayer book, you preserve the treatise of Archimedes. Yes, you preserve it. It is very safe way how to preserve some treatise. You wash up the text, it is funny, and you write on the leaves something which is useful. So you will not burn it, you will use it, and we have the text. Oh, do you understand? So thanks to the priest who palimpsested the Codex of Archimedes. And then I think we don't have to focus on some historical details. For example, 1844 visited Constantinople and the library Constantin von Tischendorf. He worked on text of New Testament from Bible, but I studied theology, but I don't like Constantin von Tischendorf because he came to the library, he saw the codex, and he thought, oh, this is interesting codex. And what he did when nobody was looking on him, he teared one page from the codex, put it in his pocket, and borrowed it at home. So, thanks to Constantin von Tischendorf, we don't have one leaf from the codex. 1899, the codex was described in catalog, and 1906 and 1908, Johann Ludwig Heiberg read it in the library in Constantinople. 1907, first publication, only method, and with many, many gaps. You saw it. And 1913, second edition, and it is substantially improved reading. And unfortunately, on this section, second edition, is not based any English translation. And overview number 2, concerning the history in the 20th century, it is extremely interesting, but I think we are mathematicians and we are not interested in details of history. So very briefly, 1920, 1921, in Turkey or Greece, it was bought, but Solomon Garrison, collector in Paris. You can ask how this codex got to Paris. It was stolen. Nobody knows how, who stole it, but I think it wasn't a clean way. And then it was in property of Solomon Garrison. He tried to sell it, and I think he wasn't successful. He tried to make the codex attractive, more attractive. So here was two drawings, two paintings of evangelists, Mark and Luke. And these paintings were not original, but these paintings were supplied in middle of 30s. So these are modern pictures. And only two evangelists, it's not enough. So after 1938 were supplied pictures of evangelists, John and Matthew. Solomon Garrison sold it to his son-in-law, and then it was in the family. But the codex was for many years in cellar, and there is damp, high level of humidity, and you can think about humidity and parchment. It is very bad. So the codex was heavily damaged, and wasn't heavily damaged by 700 years, but by last 70 years. It is a very sad history. Then, after death of their daddy, they made attempts to sell it to some world libraries, but it wasn't successful. And successful was attempt to sell it auction in Christie's. It was sold for $2 million. The book was in very bad condition, and it was heavily damaged by mold. Well, it was necessary to. It was absolutely necessary to to make conservation. So started this binding of the codex to singular leaves, and you can see that this binding of the codex took 4 years. It was extremely difficult task, and then it was possible to work on the text itself and to work of improved reading. So it was extremely interesting. We will find something new in the codex, or read the Heiberg the most what is possible. So this binding of the codex was the first stage, and then started pre-processing For example, photographs in monochromatic light by monochromatic camera with filters. One folio was scanned 40 times. It was automatization, and then was clear that we should make some we should use some improved methods. Based on chemistry, it was realized that the ink in which the text was written contains uh, iron oxide, and this iron, which contained the ink, was detectable. It was possible to detect it by X-rays, but we could saw images which are based on a map of iron content. But in the beginning, it was very slow. Only half of one light of short column took 15 hours. It was easily calculated that if we would read the whole text and full amount of gaps, that it would took 100 years, and 1 century, it is too much. So it was used generator of X-rays, which is greater, and thanks to Stanford electron-positron accelerator, it was read the part which was extremely interesting. Concerning these half of one line, here is the picture. It is a big success, but you can see that here is not Greek text. Yes, this is big success, but the Greek text is extremely difficult to read because it is not written by standard alphabet, but if you would work on codecs, you would be very happy from this clear text. On this half of line, you can see how extremely difficult it is to write with the text directly from the codecs. Transcription was 219 published. It is 4 years before. This transcription was published in this huge book, and in the first volume was published some commentary and a description of the work on the codex. This publication is not edition. It is only transcription. What does it mean? The text is full of mistakes, mathematical, grammatical. This text can be used for translation. At our university in Prague, we work on Czech translation of method because it is the most interesting treatise of Archimedes from the Archimedes Palimpsest, and we based the translation of this previously published transcription. It is the newest transcription which is uh, we have. But it is absolutely necessary to correct mathematical mistakes and mistakes concerning grammar and so on, some scribal mistakes and so on. Concerning the colophon, this is the first leaf, first page of the codex. If you think that you can't see anything, that's okay. It is very heavily damaged by mold. You can see such circles, and this is mold. It's very heavily damaged, and it was almost impossible to read anything on this page. But thanks to map of iron, we can read the text very easily. And we can see here on the margin some text which is not mathematical. This text led to datation of the whole codex. So historically, this part is extremely important. I wrote here the transcription. Egraphe diacheiros Ioannou hiereos tu mirona. Memi aprilio iota delta hemera sabato etus and stigma psi lambda zeta indictionos beta. What does it mean in English? It was written by hand of priest, and here is name of the priest who palimpsested the Codex of Archimedes. And here is exact date when the Codex of Archimedes was palimpsested and was transformed to tape prayer book. And this year is from the creation of the whole world. So in Byzantine period, they calculated from creation of the world. So if we recalculate it to our calendar, it is 1229 this year. Concerning another contribution of the new reading, this datation was absolutely new. It wasn't known previously, and another contributions of the new reading. For example, in one treatise of Archimedes, in one part of sphere and cylinder, is written, disproved by previous mathematicians, and now we read this was proved by Euclides. This is very interesting because Euclides, this ancient mathematician, is here mentioned by name. Previously, Euclides was dated, his datation was based on Proclus. Proclus mentioned that Euclides lived during the reign of Ptolemy I, and he thought that this is true because he was contemporary of Archimedes because Archimedes mentions Euclides. But where? And here we have mentioning the Euclides by name. So this is interesting contribution of the new reading. Another example, planes in equilibrium. Previously, we had theorem number 10, and this was last theorem. And unfortunately, we have nothing what precedes. But in a new reading, we can clearly read that the theorem has number 11. We have missed some theorem in another text, or some theorem is missing. Is this last theorem? And now we have no contribution, but we don't know what think about it. So it is a slightly negative contribution. And move to another treatise. I have one question. What's that? I will give some hint. I asked my wife, and she said that this is a small pig. I disagree. This is a picture from floating bodies. Floating bodies, this is treatise which contains treatises of Archimedes. And we have here the law of Archimedes, and previously it was we had it only in Latin translation, and now, thanks to this codex of Archimedes, we have original Greek text. It's excellent, but this treatise, I think it's more about physics, so we will pass it. So this is illustration to theorem 5, and the law of Archimedes spreads through theorems 5, 6, 7. It is complicated, and Archimedes formulates his law for various um, conditions. These solids are the bodies which are immersed into the fluid. This is water, and Archimedes thinks very globally, very generally. He knows that water, the surface of water, is not direct, but it is curved by Earth. So this is the surface of Earth, and these are the solids which are immersed in the fluid. So I think this is very interesting, but Archimedes lived in Syracuse, and here he saw the ships which float on the sea, and he could see the curved surface of the sea. So I think it is well understandable. But when I saw this picture for the first time, I was very surprised. Previously, I thought that for Archimedes, the surface of water is direct. In this treatise, we have more than 400 discrepancies from the Heiberg's Greek text. If you think that it is too much, these are mostly only some variants in Greek text. So it is not so bad. Heiberg overlooked one side of a folio, and he supplied Latin text. And now, thanks to new reading, after the year 2000, we have the complete Greek text of floating bodies. Somewhere, moreover, we have water instead of liquid. And somewhere in the proof, there are Greek particles, de and de. It is very slight difference, but in Greek it is not so. De and de can make another structure in the proof, but this should be examined later. Now focus on method. Here is the table of contents. It is on 2 slides, and we can see the method of Archimedes, introduction, 2 theorems, and one of the theorem is the theorem which we saw in the text of Heron. You will see this section of cylinder. This is the first theorem, and the second theorem speaks about intersection of 2 cylinders, which have their axis perpendicular and which can be inscribed into one cube. The intersection forms this solid. And what are the results? This dark part is 1/6 of the parallelepiped, and this intersection is 2/3 of this cube. These are very interesting results. Intersection of 2 cylinders, and it is 2/3, no p, no pi, but it is 2/3 of the cube. Archimedes was very proud when he wrote to Eratosthenes about these 2 theorems. So this is introduction, and then he have some lemmas, and here are theorems which illustrate his method which let him generate new results concerning center of gravity and concerning volume of some solids. And here we have determination of area of parabolic segment, volume of sphere, volume of ellipsoid of revolution, volume of segment of a paraboloid of revolution, and determining center of gravity of this segment of paraboloid of revolution. Concerning the theorems 4 and 5, these are the easiest theorem in the method, so we will demonstrate the method of Archimedes on these 2 theorems. And what more, boldly are highlighted the theorems which are improved in the new reading in the last 15 years concerning the center of gravity of hemisphere, generalization to half of ellipsoid of revolution, and determining of volume of general spherical segment. And then this continues, and here we have absolutely new theorems concerning these solids. The first concerning this section of cylinder, we have proved in 3 ways, and the final part where should be proofs concerning the second theorem, the intersection of the cylinders, we don't have extant. So we can't read them, and we can only reconstruct the proofs. Concerning the lemmas, Archimedes reminds some trivial results where are center of gravity of simple bodies and simple figures, geometrical. Here is one lemma. It is funny that the Greek text is extremely difficult to understand. It speaks about 4 groups of quantities, but nowhere is said about which group we speak now. So there are one group, quantities, quantities, and quantities, and these quantities and that quantities, and nobody knows about what Archimedes speaks about. So it is extremely difficult to understand the mathematical point of this lemma. Concerning the theorem 4, we will determine volume of paraboloid of revolution. It is here, and we will determine its volume. And it is very nice result, because volume of the segment of paraboloid of revolution is half of circumscribed cylinder. Here we have the cylinder. Here is the paraboloid of revolution, which is into the cylinder inscribed. They have common base, and the paraboloid takes 1/2 of the cylinder. It is very nice. Here we have planar section. So here is the paraboloid of revolution, and it is parabol. Here is not cylinder, but cone, and it is reduced to triangle. And this is the cylinder. And now think in the terms of analytical geometry. I would be, so this is x axis and y axis, and here we have y is equal a multiplied x the second power. And you can see here the equation of parabol. And here you can see here the equation of parabol. And it is absolutely general. If you miss here some coefficient, yes, it is one parabol, so the coefficient can be eliminated. So we have a delta, it is y, is equal B delta. B delta, we can see it on the x-axis, and A sigma. Sigma is some point on A delta, and we have the same equation of parable. And based on this, we can continue. This is equation, and A delta is equal to A theta. This we can think about this like about lever. This is one part of the lever. This is second part of the lever, and we will balance. And the lever is supported here in the point A. So in the middle of the lever. And we can continue. B delta is equal to M sigma. Wow, B delta, M sigma, yes. These lines are equal concerning the length. And we can write it. I will substitute A theta, and A sigma is equal to, and it is substitute. And now you can see here the pi number. And what is it? Pi multiplied r. This is area of circle. The pi can be eliminated, so it is not written here. But I can think that here is pi number. So this is area of circle, and this is area of circle XO. And the circle MN, it is circle in the cylinder. And XO, it is circle in the paraboloid of revolution. And here, the denominator I can put here, and A sigma I can put here, and I have this equation. And this is well-known law of the lever, well-known from the basic physics. And here, A theta, this is one part of the lever. This is R1. And what is here on the, what is hanging in the point theta? Here is hanging the paraboloid, because I can work not only with one section, not only with one circle, but I can do it with all the circles in the paraboloid and in the cylinder. So to the point theta, I can hang the whole paraboloid, and to the point sigma, I can hang the circle from cylinder, and the whole cylinder will stay on its own place. And I can, this cylinder, hang into the center of gravity, which is in the middle of his axis. It is the point K. And now we have finished the calculation. The volume of paraboloid we don't know. AK. It is half of the axis. Well, here is the half. And volume of cylinder we know very well. So the only unknown thing is volume of paraboloid. And what is volume of paraboloid? It's 3/2 of 1/2 of cylinder, or one cylinder is constitute from 3 cones, so 3/2 of inscribed cones. So it is very simple method based on method of lever, law of lever. And if you want find center of gravity of this paraboloid of revolution, well, it is not difficult. We know its volume, and we can put the calculation in a such way that everything is known: volume, center of gravity of cylinder, volume of cylinder, and we don't know the center of gravity of paraboloid of revolution. And the paraboloid of revolution will stay on his own place. I will make the calculation. Well, we have the same beginning. This is based on equation of parabol. And we can continue the calculation. A delta, and B delta is the same. A delta and B delta is the same. A sigma and P sigma is the same. And we can add B delta, so this is second power, and here it is multiplied. And we will start with this equation. What we will obtain? This is our starting point. And moreover, compare it, this one and this one. Beginning is the same, A delta to A sigma. So end should be the same, but denominators compare it, and you see that sigma xi is equal to B delta and pi sigma. And divide this equation by B sigma, the second power. And we obtain this equation. And now we can interpret it using the law of the lever. How? B delta pi sigma, xi sigma, the second power, and pi sigma, the second power. And here you can imagine the pi number. And we can see here the area of circle in paraboloid and area of circle in cone. And if we think about all the circles in paraboloid and about all the circles in the cone, we have this equation and interpret it. This is a classical law of the lever. We have the whole cone, which is hanging in the theta, and the paraboloid is on his own place, and we can hang it in his center of gravity. Center, so T. But we don't know where it is. Well, cone, and cone is 1/3 of cylinder. Here we know concerning a parabola that it is half of cylinder. We can put everything to the left side, and we have AT is equal to 2/3 of axis. And what was the result? It should be proved that it should be in the on the axis, and the center of gravity of parabola of revolution divides its axis so that the part of the vertex is 2/3. So P is something here. Hmm? So this is a method of Archimedes. We can easily calculate, for example, volume of sphere, and it is 4 times of inscribed cone. It can be easily proved. Here we can imagine the lever. It is supported here in the center of the lever, in the point A. Here we can think about this product. M sigma is equal to gamma A, and A sigma, sigma E. These are equal. And from theorem of Euclid, here is a right triangle. You can see it, a right triangle. It is in the circle on the diameter. So we have AC, the second power. And from theorem of Pythagoras, we have this one. And then we can improve this to such equation. And here we can see the pi number, and here the pi number, and we can interpret it as areas of circles. And what is M sigma? M sigma is circle in the whole cylinder. Xi sigma, it is a circle in the sphere. And sigma pi, it is a circle in the cone. Well, here is the interpretation, and we can calculate it. Cylinder, sphere, cone. We have all the circles in the cylinder, all the circles in the sphere, all the circles in the cone, and we obtain such equation. Volume of cylinder we know very well. Of the cone we know very well. So the only unknown thing is volume of sphere. And after these are only recalculations concerning one body inscribed cone. So we recalculate it. We obtain that sphere is equal concerning the volume for inscribed cones. So this is the ingenious method of Archimedes, the method which leads to finding volumes and centers of gravity of various solids. And our times is at the end. So thank you for your attention, and best of luck for tomorrow.